Hello, welcome to my bench. Today we have something rather special. Well, at least it's special to me. When I first started working on radios back in the early 70s, 1973 to be exact, this was what I was working on. I had just gotten my FCC license, and I got hired by a guy in Georgia, outside of Atlanta, to do his CB radios and sign them off. And he set me to work fixing these old Johnsons. This one is a Messenger 1, and in the old days we called it a white face, which was, it's silver, but not white. But the other one that came out, the Messenger 2, was a black face. Half of it was, well, 2/3 of it down at the bottom here was black. And it was 10 channels instead of 5. And it had better receiver. I think it was, this is single conversion and a couple of IFs, and the 2 had 4 IFs, I believe, and another set of conversion. So it was a better radio all around, but this one's the original from around 1963. I cannot find the date on this one, and I have not done anything to it. We're gonna hook this thing up together and see if see what happens, see if we let some smoke out. But first we're going to take a look at it. On the front here you have an on light, you have a transmit light, you have a squelch and an on off here, and volume over here. Here's your 5-channel selector for your 5 crystal controlled channels, and the speakers in the middle. If I remember correctly, I believe I think it has a transformer coil on it, but I don't know, I'll remember. And this one is in pretty fair shape for its age, I gotta give it that. Now, these radios were used a lot back in the 60s, up to 72 or so, by companies. They'd put them in cars, and they'd have base stations, and they'd use them for business, which is perfectly legal to do for a business radio. That's what it was for back in the day. And they were pretty good radios. The FCC at the time limited these to 3 watts out. There are many conversions that can be done to them to put out more power. They're all tube, so they suffer well being abused. However, I'm not going to do that to this. This is going to be stock, I believe. We'll find out when we open it up. The only thing I've done is take the screws out of the back. It is missing a couple of feet down here. And I have the manual for it. So I guess we'll just take a look at it. If we tip it over here, you notice that the microphone is nicely attached. There's no plug on these guys. If we tip it over on its back, we'll see that it has a SO239 output and a 9-pin, I believe. Yeah, whoa. That is in there. There we go. Yeah. 9-pin octal. Or 8, or whatever they call it. Tube socket. That fits on here. If you get one of these guys and you're going to work on it, by the way, if you're going to work on it, you're doing so at your own risk. There's high voltage in here, up to 450 volts, depending on if it's been played with or not. And a lot of them were. If you get one, make sure that this little guide is still there. If this little guide is not there, be very careful plugging this guy in, because these things also worked on 12 volts. with the appropriate vibrator, and the wiring on the plug is different. Does this one actually have all the wires? Yeah, it does. But if this is gone, you could plug this thing in wrong, and there would be much magic smoke leaving. So be careful. Anywho, let's open this up and see what we got inside. Ooh. I wonder how much this has been messed with. Ooh, there we go. Put you right down here, out of my way. And here is the radio. Let's take a look at it. Boy, does this bring back memories. The guy I worked for was kind of crazy. He, when I first started working on them, specifically these, and after I'd been there for, I don't know, few days, he stood behind me without me knowing it and put his foot on the bottom of a long 2x4 and his hand on the top of it and held it and waited till I plugged it in. And as soon as I did, he let that 2x4 go and it hit the ground. I jumped clean out of the chair. Seems funny now, but at the time it was kind of, you jerk. Alright, so let's see what we got here with this thing. Over here is all your crystals. 10 of them. One transmit, one receive. Power supply, filter cap going to ground. That's a vibrator. It actually has its vibrator. Wow. In case you guys out there don't know what a vibrator is, it's basically it creates voltage, wow, by vibrating. Just like, well, it's kind of like what they do now in switch mode power supplies. Yep, 12-volt replacement vibrator. So this one was run on 12 volts. It's a Mallory. And the plugs on them, 2 of them are a little bit bigger than the others. And quite frankly, looking at it, trying to figure it out is kind of difficult. It only goes in one way. No, yeah. There we go. Fortunately, they're big enough so that they won't fit in there. You can jam them in and kill it. Don't do that. Basically, what this thing does is it vibrates back and forth and closes and opens contacts and creates spikes at whatever frequency it runs at. I don't really know, to tell you the truth. And comes up with the replacement voltage for this by rectification. So it's a self-contained little buzzer. It only works on 12 volts. So when you use the thing on 12 volts. So we got a bunch of tubes, and what's this? Oh, well, that's kind of interesting. Somebody decided to just bypass the light bulb instead of replace it. And according to this, it's a neon NE51H. That's why, because it's a neon light bulb. Might have to get one of those if I'm going to put this thing back. This is in for repair, not for full restoration. I'm basically just going to do what it needs and get it up and running. And I'm going to do that with you all. Like I said, here's the choke coil for, I believe, yep, for the speaker, transformer, and a bunch of tubes. What do we got here? We got a 12AU7. How do the sockets look? Wow, this thing is nice and clean. Original E.F. Johnson tube. Ha! 6AW8A. Nice. What's this one? Is a RCA, and it's a 12AB5. When you take tubes out, by the way, I mean, this is all over the web, everybody knows this, but when you take the tubes out, you kind of rock them a little bit to get them out. Don't try to pull them straight out. You won't do it, and you're liable to break the tube. Here's another E.F. Johnson 6BJ6. Okay. Interesting that one has a place for a tube cover, but no cover. So does this little one over here. What's this? 6. Well, hard to get out. That's what it is. Okay, we're just going to leave that in there. It's an E.F. Johnson also. And I can't see what it is. We can find it on the schematic. This guy is another original 6BJ6. And I don't think this thing's even had the rectifiers taken out. I haven't looked at the bottom yet. I don't know. Here's another E.F. Johnson marked with the E.F. Johnson logo on it. 12BE6. I can't believe these are E.F. Johnson tubes in this thing. My word. I wonder when the last time this was used. RCA on this one, 12AB5. And, this one is, I believe, an E.F. Johnson. Yeah, it is. E.F. Johnson. And this is a 8077 or 7054, which is an 8077 tube. I don't know what the cross is on an 8077. I really sincerely hope these tubes are okay, because I don't have any. And this one is a 12BW4 rectifier, I believe. And this is a tongue saw. Wow, okay. So we have one big filter cap here on this side and one here, over here. Can't see. I wish they wouldn't do that. When you put the caps in, let's see, what is this? This is 40 microfarad, 450 volts. And there's lots of tuning in this. And nothing is broken that I can see. That's good. All right, well, it's looking pretty good. Dusty and dirty, but, we'll turn it over. Here we go. All right. Well, it does not look like it's been touched. No, it does not. Here's a Sprague over here. It needs to be replaced. Bumblebee, it needs to be replaced. This needs to be replaced, and this one. And how many... where'd it go? Way up here. So there's 3 caps in there, and they need to be replaced. Yeah, oh, and this one. Ooh, that's nice. 150 volt. I don't know, but its guts are coming out one end down here. And we got some... All the resistors, or most all the resistors, are good modern style. None of the old ones. Well, there's one there. What's in this? I think that's a cap over there. I don't know, or a coil. don't know. We'll look them all up and find out. It's a little greasy under here. We'll look and see on the schematic if the thing has a death cap going across the line. If it does, we will be changing that out. Okay, down here, this is the relay, transmit receive relay. You can see there's a wire that goes right over to the input output. And there's the relay contacts. Let's see. Here's the input. Yep. That's it. All right. Well, that's amazing. This thing has not been touched ever. Shows you just what a workhorse these little old buggers were. Says this thing's probably 63. I wish I could find a date on it. I don't see one anywhere. It's not like you can look at one of the ICs and find out either. Well, okay. It's got really nice sealed pot there for the switch and the squelch and on-off switch. The volume isn't. It's just one plain old pot. Yeah. All looks good. Well, tell you what. Considering the shape this thing's in, I think we'll just kind of ramp it up and see what it does. Why not? Because, no guts, no glory. Is that it? One thing I do want to check before I plug it in here, well, after I turn it on, I want to make sure there's no voltage coming out of the antenna connector. That would be bad. Okay, so I got the dim bulb tester on test. Switch is on. Squelch is on. I wonder if this is one of those backwards squelches. I don't know. Some of these old ones, the squelch was off when you turned it all the way to the right. I don't remember anymore if this is one of them or not. Anyway, we'll just leave it in the middle. And put on current, and we'll bring it up on power and see what we got. The dim bulb is working. We got no high current. We're up about 105 volts. And the dim bulb is going out. Do I have any voltage? And I got no voltage coming out of there. Good. So, anybody lit up in here? I'm going to take some lights down. I can't see anything. Hang on. Lights out. Wow, that's a pretty good camera. Well, that's on, those are on. Those are on. Yeah. Wow, okay. Well, it appears it's drawing some current. Quite a bit of it, actually. Well, the dim bulb is about lit up. So let's watch and take it down, turn off the bulb, see what my current looks like. We're sitting at about 250 milliamps at 110 volts, drawing 67 watts. And holy smoke, We got audio. And all of the little tube lights are lit. Okay, we just got to find out now. Wow. Let's plug in the Motorola. Let's see, this is on channel, what, channel 9? I'm sitting on channel 9. Or no. What am I sitting on channel 9? 27065. Yeah. Let's see, frequency 27065. Switch is dirty, but we got receive. But that's minus 72 dBm. Starting to smell a little warm. That's 55 microvolts. There's 5 microvolts. There's 1.7. Holy Hannah. These things were only good to about 1. Wow. Listen to that. Alright, well, let's get this thing going here. And get you over here. Zoom you in a little bit. Whoops, that wrong button. Turned it off. That wasn't good. Alright, and let's find out what we got. So we got 27065. Start her up. And let's see what happens when I key it. Oh, it went click. 2.67 watts. Frequency error 100.15 kilohertz. Hello, no audio from the microphone at all. Show you. Hello. Boy, that is one uncomfortable microphone. But I can't believe that. 150 0.15 kilohertz off. And no hum that I can see. And it receives, there's 0.48 microvolts. And I can hear minus 109. Wow. Holy smoke. That's amazing. For this age. I don't believe it. That is just amazing. So now, the job is simple. Replace the caps. Holy Hannah. And clean the switches. I am just amazed. Let's turn this off. 67 watts. Well. Well. That is amazing. You know what? We're probably going to have to see if the vibrator runs. Cool. Ah, good old boy. These things are a workhorse. Well, they carried them around in taxis and delivery trucks and big old dump trucks, talking back to the base stations, and I mean when these things were used, they were used hard. And evidently, they're pretty good. Alright, well, I'll tell you what I'm going to do. I'm going to go through this thing, replace all these awful caps. That one's warm. That's why it's spitting its guts out. Replace these awful caps, And I'm going to check the big high value resistors. There's a couple of big, like 1 megs or better in here. And then I'm going to clean it up a little bit, just because it deserves to be. And we'll be back, and we'll do an alignment on it, although don't need much of one, that's for sure. Wow, good girl. I don't know what this is, but she is one survivor, I'll tell you that. Okay, we're back. I got all of the caps replaced that needed to be replaced, and I checked all the big resistors. Well, I checked most of the resistors. I got a couple of 0.473s and a 0.047, yeah. 0.047, and 0.1 there, 0.1 down there. The big cap over on the side over here, it was 10 at 160, 15 at 350 or something like that, and 10 at 25. And I got the in here, best I could do on that one. Fortunately, this one here, the big cap, the 15, which I put in at 22, there was a binding post here that wasn't being used, so I could use that. And it goes on over to, what pin does it go to? The 15 microfarad goes to the screen of V6, which is the modulator tube, which is this one here. And that's this one, and then this one here, which is a 10 at 160. It's supposed to be 150. I didn't have any, so I put a 450 in there. It goes over to the between the cathode and ground of V5, which is 1/2 of the second audio amp, which is half of V5. And these two guys over here, which were 4.7 microfarads, which is in the audio circuit. I just put a 450 in there, and a 4 microfarad, 4.7 in the place of a 4, and a 4 microfarad or 8 microfarad down here, which I put in a 10, which goes to the coil, one side of the coil of the relay over here. So then the rest of everything tested out okay. This big one back here is for the only works in the vibrator circuit. So all the caps are replaced. Now we got to figure out why we got no modulation. So let's get this canvas sort of set up here so I can show you. Turn it on, let it warm up. It draws about 60 watts when it's up and running all the way. And we got a fairly low level of audio. I noticed that. I mean, it sounds, it's okay, but it's kind of low. It should drive you right out of the room, but it doesn't. Anyway, and if we look at my audio, this is set up for audio. Turn this around so it doesn't fall over. That'd be good. And if I transmit, nothing. There's nothing out of there. So let's take our voltages first. Let's see, the tube that we're messing with is this one right down here, which is a 12AU7. Get a clamp here. 12AU7. If we go down and look at the schematic, okay, if we go over and take a look at the schematic over here, what we've got is the 12AU7 here, and it is the first audio amp. It comes off of the detector right over here. Comes on through, it's part of the noise limiter down there, and the volume control. Comes up to the audio amp right there, and it goes, let's see, when it's in regular receiving mode, it uses this side of the amp, which goes on out through down here, and lost what I was doing. Whoops. Sorry about that. Why did it just jump on me like that? Anyway, this line right here goes out to the part of the second audio amp, which is part of this V5 6AW8, feeds the grid and through into the modulator for the transmitter. Alright, so we should be able to see what our voltages are here. Can we see our voltages? Yeah, pretty well. Alright, so let's take a look at pin 2 in transmit. Should be minus 0.5. Where's pin 1? There's pin 2. I got nothing in receive, which I should have. I got pretty much nothing in transmit also. So if we turn this thing off and go to ohms, make sure we're no voltage there. Well, this meter would recover, but I don't try to test it. We should have about 4 or 5 megs, which we do. Okay, so that means that means nothing. No. That means we got wrong voltages there. So let's crank it back up. Tube sets, gotta let them warm up. Here's the pile of tubes I took out. Okay, so now let's go to pin 1 in voltage. And we got about 28 volts. It says 25 right here. Yeah. And on transmit, we got 150 volts. Well, that ain't right. We're dropping through a 220K coming off of pin 6, which is this one right here. We got 29 in receive, close enough. And about 160 in transmit, close enough. So we're not dropping any voltage across that resistor, which means either that resistor is shorted, serious doubtful, or this tube is not drawing any current, or darn little current. It's drawing, well, what's our difference here? Let's see if we can figure this out. Okay, so we got 100 and let's call it 160 there on one side and transmit, and 164.5. So we're dropping 160, 1, 2, 3, 4, 4.5 volts. So if we do the old thingy, I equals E over R, so we got what? 220K So we got 4.5 divided by 220. Whoops, wrong. 220,000. 220,000 equals nigh on nothing. Triple quad 0240. So that tube is not conducting, or almost not conducting at all. That's why we got no audio. Not darn any current. So that is a 12AU7. Well, hang on. Let me see if I can find the tube. I'll be back. Okay, I don't have a 12AU7. Doggone it. However, I have the 12AT7. They are not the same tube, and the voltages will be off, but we'll at least be able to see if it's working. Yeah. And I did take this to test it. It's not shorted, but it sure as heck doesn't do anything. I mean, it barely picks the needle off the peg when I tested on my old antique tester that I fixed. So I more or less trust that thing to be approximately right. So, but the 12AT7 will work in here. There's just the voltages won't be right because of the different transconductance of the tube and a bunch of other stuff. But we'll be able to see what happens. Now we got noise. Now it's loud. Yeah, quite loud. Okay, so let's see what happens when I transmit. Oh, we got audio. Look at that. Radio. All right, well, let's see what our voltages look like now. Pin 1. Remember, these voltages are not going to be what's called for in the manual. Much higher. It's actually a better tube. So I got what, 12? Well, let's see. I'm supposed to have 25. I got 77 volts, 78 volts on there now on pin 1. And when I transmit, I got 47 volts where I should have 17.5. So they're about even on both sides. Let's see what we get here. Now on pin 2, on transmit I got minus 0.9, which is I'm supposed to have minus 0.5. So that tube was definitely bad. So just for fun, let's do our measurements now across this resistor and find out what we come up with. So we got on one side during transmit, I got 183 volts, and this side I got 49 volts. So if we take it 183 minus 49 equals 134 divided by 220,000 equals, there we go, 0.0006. So 6/10. 2 orders of magnitude more than we were doing before. So the tube is actually conducting and doing what it's supposed to do, which we saw on the meter, so the scope. So yeah, that's what it's supposed to do. I'll tell you what. Let's just hook it up to this little guy. a little slap together. Basically, it's got some resistors in there that equal 50 ohms, good for 4 watts, and an RF out with a 100K, or I think it's 100K tap or resistor coming off of the center point of it. Works really well. Gives me just enough. Gives me just enough to be able to test these CBs. I don't do a lot of CBs, but let's see what we got here. What am I sitting on? 20 millivolts? Well, probably, yeah. Let's see what I get here. All right, there's my carrier. That looks pretty good. And we'll talk. Spread that out a little bit. Yeah. That looks like about 100% modulation. And if I yell into it, it'll clip. It'll go down to well over 100. Which we don't want, but we'll check that out when we do the what do you call it? I forgot to turn it on. Okay. Now we're recording. So we got, there's my carrier. Looks good. Yeah, looks fine. And there it is with modulation. Hello, radio. Yeah, I'm never going to be able to, let's say, at a solid tone. These microphones, you've got to eat them. But that looks good, all because of that tube. But we can't leave it in there. We're going to have to take that, get a 12AU7 for that thing. But for right now, it's working like it's supposed to. 27205. All right. Okay, so okay, enough noise. So let's take a look and see what we got here for frequencies on this thing. Okay. Ugh. All right. So here, yeah, nice. This is, yeah, this is channel 15. It is dead on frequency. So we got channel 7 and channel 7 27035 frequency and down one, and that's 730 hertz off, 0.71 kilohertz. That's good. Then we got what it'll do. Then we got channel 9 27065. That's 150.15 kilohertz, 0.14 kilohertz off. Good audio. And we got channel 11, which is 85. Okay. That one's off a bit. 1.9 kilohertz low. And it's only got one adjustment. The crystals have got to be right. So, not much we can do about that. Back up and show you channel 20 again, which is 27205 to there we go. And it's 1.7 kilohertz low also. Okay. In AM, they'll still be able to hear you, but it ain't right. But you can't adjust anything because all you got to adjust on these is back here. There's one little coil right down there. So if your crystals aren't correct, you're just out of luck. So it needs new crystals, or take these antiques out and open them up and shave them down. I don't think anybody cares. I think somebody just wanted this working, and he can go on channel 15. I'm going to have to order that light bulb right there. I do not have a neon bulb of any sort to go in there. I'll see what I can find though. Alright, so we got the receive working, we got the transmit working. Well, let's see, the receive, let's see, let's put on 15, since we know that that's a frequency that is working. 135. Okay. 135. All right. Excuse me. We're just going to do a quick IF here and see if we can get this to sound a little bit better. The IF is down underneath here. It's pretty good anyway, just the way it is. And for the IF cans on this, got to use a real screwdriver. Give me a little more here. By ear, that's about right. And then, let's see, we are on channel 15 high, so that would be the bottom one. Then we're going to tune this can, which is T3, I believe. If I remember correctly, yeah, it's T3. I want to tune that one on the bottom side for the higher frequencies. There we go, and let's go to channel 7, which is the lowest frequency I got here, which is 27035. 035. Whoops. Hello? Channel 7 crystal doesn't want to run. Oh, the channel 7 on receive is no good. Alright, well, let's do 9. Oh, 6.5. Okay, so 27065, and that's the top for the low channels. Okay. So we got 1.3 microvolts. So as you can hear it. What have I got? Modulation wise. Oh, there's 50% modulation at half a microvolt. That's pretty good for these guys. Okay. Well, that appears to be working. So all we really had is funny when these things, they always did this. When you hold on to the good old metal microphone here, it'll quiet down on you a little. It's just the way they're built. You just touch anywhere on them. So we have a problem with the channel 7 crystal. Sure enough do. Let's turn it off and see if it's just crystal socket. Probably not. You know, unfortunately, only crystal company in the country is gone. International Crystal is no more. And we don't have a place to get crystals anymore. Okay. So 7 received, 26. Oh, it was halfway out. There ain't much holding them in. Luck. Yeah. I don't think it's the socket. Let's put channel 9 in there just for the heck of it, see if it receives. Yeah, it does. And it's on channel 9 on the generator too, so I guess sounds springy and okay. Okay, let's take it. Whoa, wait a minute. I tapped it. 035. We got it. It's iffy, but it's oscillating now. Yep. Okay. Well, like I said, don't think I'd guarantee it, but we have a functioning radio. I wonder, transmit, receive. I'm not going to do any more to the receive, as far as receive sensitivity goes, because that's all there is, really. But let's look over here at the transmit alignment. Where is it? Yeah, come on around. Okay. If you look over here on the transmit alignment, you've got this grid for this L5, which adjusts the oscillator. It's the oscillator grid coil. You adjust that plus or minus 100 hertz. Well, that's all you've got with all the crystals. It's not like there's separate ones for each individual one. And it says power output PA under 22 milliamps or less. Okay, adjust L9 for a dip in the PA voltage current. Do we want to go through all that? Hang on, let me get some stuff set up. All right, well, we've got everything hooked up like it says to in the manual. We've got. Let's go back up here and just show you what it wants you to do. It says the test equipment and connections, which we're doing this right here. We have an RF pickup, which is this guy, going to the scope. We have a connection to the DC voltmeter at the junction of R48 or C48 and R46, which is R46 and R48. Oh, okay, that's the 3900 ohm. That's this one right here. This is the guy that limits your power on these. That's what everybody changes to get more power out of them. So basically, the drop across that resistor is what's going to give us a reading for our it says connect the DC voltmeter across R46, the 100 ohm meter shunt. This will give a positive terminal. Each volt will represent 10 milliamps of PA current. Okay, and what we're going to do that with, the 10 milliamps of PA current is going to be on this meter right here. The other one is on R6 and C46, which is up here. And that is going to give us relative indication of the PA grid voltage. And that's going to be over on a meter that I will have to set up here for you. If we go down to the if we go down to here, it says check your frequencies and adjust your coils. Well, yeah, we can't. We did what best we could. The crystals are off frequency. And then it says to adjust L9 for a dip in the PA plate current by adjusting C49 for the desired plate current at the dip, and the coupling will increase as the capacitance of C49 is decreased. Make the last adjustment of the tuning of L9 for a dip in the current. So what we should see over here on this meter is we're going to go for a dip in the PA current. Right now we got 2.2. Well, that, wow. Go for a dip. 1.7 is about as good as I'm going to get it. Okay. Yeah. And it's staying about 1.7. And then I also do a dip with this one. Oh, wrong way. Okay, and go back to this one. Can't see what I'm doing there. Ugh. To adjust it to your desired amount. We want about 2.2. This is what it says it wants now. That is somewhere kind of touchy. Wow. So that would be 22. 21.5. Alright, and then this one should be dipped. And then back to this one again for 22. Or $25. And right there. Alright, so that's dipped it on both sides and about as close as I can get it, because I'm telling you that is really touchy. And let's take a look at our power. 2.95, and this is a 3-watt radio. I'd call that pretty good. And let's look at the scope off that pickup. There it is. Hello. What did I do? Oh. Sorry about that. I moved the... Hello. Hello. Ah, beautiful. It's hard to whistle when you got to eat the mic. Alright, so we got that. That's right. 3.9 volts. Now, what else have we got? Down here, it says normal neutralization is only needed when V8 has been replaced. Key of the transmitter And note the PA grid voltage is L9 PA grid voltage. Okay. Which is, at this point, come over here. Okay. PA grid voltage is right about, minus 12, 11.8, 11.9. Okay, so it says if the voltage decreases as L9, that one we were fooling with before, I'm going to make sure my little flag here is pointing so I know where to put it, is if it increases when I turn further into the coil, then the value of C44 is too high. So let's see. No, it does not move. So that's okay. All right. And we're still back. Yeah. 2.96. All right. So we didn't change C44, so we don't have to worry about that. Okay. We don't need to do this because right there, because we didn't replace C4 and it's working just fine. So the neutralization is okay. So what else we got? That's it. That's all there is for the transmit. So we got our receive set up to 1 microvolt or less. Our transmit is 2.96 watts, which is what this thing will put out, 3 watts, and everything. So we basically got it. That's it. We got a finished radio that works nice and heats up the shop. And well, it's tubes. What do you expect? So, if you guys want to make one of these, basically it's just 2 loops of, I use solid wire here and hooked it up to the end of some RG58. And put a BNC on the other end. Works great. It's fantastic pickup. Cheap. Works fantastic. All right, so that's it. That's what we got. What did we do? Well, cap replacement. That's pretty much a given. And and checked all the resistors to make sure they were fine, and they were. And we did not have any audio out of this microphone. And we traced that down by measuring the voltage drop across the resistor that was dropping the resistor voltage to the, what was it? The plate? No, it wasn't the plate. Was it? Yeah, to the plate of the audio amp, which is right here. So we measured the drop in resistance or voltage across there, 220K, and we ended up with 0.4 zeros and 4 or 2. So we had almost no drop whatsoever across there, and from that we deduced that this side of this tube, or whatever, right there, wasn't working. That's one way to check a tube. The other way is take it out and take it over to the tube tester and test it, and this thing, the whole tube, came out at just dead. I mean, it was gone. I didn't have a 12AU7, so I stuck a 12AT7 in here, and it's a different tube. It's going to have different voltages, but we were able to measure across this R23 again, and we had like 130 volt drop, or something like that, and at which point we were able to get 6 microvolts, 6 microamps of current. No, 600 microamps, almost 1 milliamp of current. We knew that this tube was working, and we also knew that because it was receiving or louder and it was transmitting louder. But that's how you do, that's one way to do a tube, to find out if the tube is bad or not. And we did a simple alignment on this. Alignment on this is really easy. You've got that right there, that coil. Tune that for the RF amplifier. If you look back at here, you got very little in the way of input tuning, almost nothing. So you just tune the amp, that amplifier can for the RF, and then make sure there's your crystals. You tune the 455. There's one of them. And here's the second 455, you tune it, and that's about it. There isn't a whole lot more to do. This stuff here for the noise limiter, I checked that diode, it does work, but the noise limiting on these is pretty much nothing. It works in a car, sort of. Not great, but it was what we had. That's what we used to have. We used to go out and get noise suppressors that we put in the car right on the coils to keep some of the noise down, because we didn't have the nice noise suppression that they got now. Anyhow, so that's what we did. It's all done. I can pack this thing up and send it back to the guy and tell him channel 7's a little flaky and channel 15's right on frequency. If he wants to buy crystals for it, he can do that. I'm not going to do it because, well, we don't have any place to buy crystals anymore. And secondly, I don't think anybody's actually going to use this. I can't imagine anybody actually using this radio. But if they do, it'll still work. Now, I am going to order and get one of these tubes. It doesn't take that big old tube. I guess it does take that big old tube that's there. But I'll get one of these neon bulbs and put it in there, and that'll make him happy too. All right. Well, there we go. Old Johnson Messenger 1, all done, ready to go. Cleaned it up a little bit, spit polish it, dust it out, and we'll have a nice running radio. Hey, if you like the video, give it a thumbs up, and don't forget to subscribe. Hit the little heart button if you want to know when I'm doing more of this stuff. And thanks for watching.